In this guided tutorial, we will simplify this complex fraction, and then we will verify our solution using the graphing calculator. There are two methods for simplifying complex rational fractions or expressions, and what we're going to use is we're going to find a common denominator in the numerator and get one term there. We're going to find a common denominator in the denominator and get one term there. And then we're going to use multiplication properties and division properties. So let's start with just the numerator. I'm going to get a common denominator of 3r. So my numerator will have a common denominator of 3r. In order for this first fraction to have a common denominator of 3r, I'm going to need to multiply top and bottom by r, and so I'll get r squared for that first fraction's numerator. Minus, for my second fraction, I will need to multiply top and bottom by 3, and so I'll get a minus 9. So I've combined these two by getting a common denominator for both. This one was r squared over 3r, and this one was 9 over 3r. So I'll get r squared minus 9 all over 3r. I'm going to do that same process in my denominator, only in this one the common denominator is 4r. This fraction will need an r top and bottom, and so I'll get an r squared. And then a minus. This one will need an 4 top and bottom, so I'll get minus 16. And it looks like I then have r squared minus 9 over 3r over r squared minus 16 over 4r. Now what I need to remember is when I have two fractions that are being divided, I take the second fraction or the denominator fraction, I flip it, and it turns into multiplication. So I actually get two fractions being multiplied. The first one stays the same, r squared minus 9 over 3r. And the second one gets flipped because dividing by a number is the same thing as multiplying by its reciprocal. Just like dividing by 2 is the same thing as multiplying by 1/2. I'm using that idea here. So I have 4r over r squared minus 16. And then I can just simplify by multiplying straight across. So I'm able to get one whole fraction where the numerator is 4r times r minus 3 times r plus 3, because that's a difference of squares, that r squared minus 9. And in the bottom I get 3r over r minus 4 times r plus 4, because I have another difference of squares. And then I have to look and I say, can anything cancel? My 4 and 3 cannot cancel. My r's can. Those are factors of the numerator and the denominator. So it looks like I can cancel those r's, which will give me a final answer. Let me see if I can just... of 4 times r minus 3 times r plus 3 over 3 times r minus 4 times r plus 4. Let me check that answer first of all. Let's see if it'll let me do that. I did factor completely. It probably did not like me using all those parentheses. So let's try it using their fraction bar. So I'm going to get 4 times r minus 3 times r plus 3 over 3 times r minus 4 times r plus 4. Looks great. It's right. Now how would I verify that on the graphing calculator though? I'm going to go to the y equals, and I'm going to put in y1, my very first fraction, Ooh, that's going to take a lot of parentheses. So my numerator will need to be in parentheses, and I'm going to get r over 3. I'm going to use x instead of r, so I'm going to have x over 3. I use my division bar for over, minus 3 over r, which I'll use an x. That's my numerator. And I'm dividing that by, and now I need to use another parentheses, x over 4 minus 4 over x, end parentheses. And I'm going to enter that. And then I'm going to put my final answer, which I got. I'm going to use parentheses, 4 parentheses x minus 3 parentheses, parentheses x plus 3, and that's the whole numerator. Notice I had a beginning parenthesis in my numerator and an end. And now I have divided by, and now I need another beginning parenthesis, and I'm going to have 3 parenthesis x minus 4 parenthesis x plus 4, and then that ends the x plus 4. This ends the entire denominator, and I hit enter. And then I'm going to go to graph. I'm seeing that they're graphing on top of each other. It's probably maybe easier to look at the table. Let's look at the table. So for the table, if any x value I put in, both of those functions return the same. Let's say I put in x equals 104. Then they both return 1.3342. And so these two expressions are the same.